So it's projectile motion. And the question is the following. So what angle we need to shoot for the cannonball? So to make it travel a maximum distance with initial velocity v0. So this is the question we're going to talk about. And so first we need to think about what's really going on physically. And there is some initial velocity and there is an angle theta with respect to the horizontal axis we have. And so it's kind of like it's gonna traveling like this way. It's gonna reach a maximum height and then hit ground over here. So and the equation like really governing the behavior of the motion of this cannonball is the following. So it's basically have two components. So it's a two-dimensional motion. So in x direction, it's moving like with a constant velocity, but in y direction, it's basically moving like in free fall. It's only gravitational forces acting on it. And so, by the initial velocity, we can also separate them into two components, the x component and the y component. And so we can also like represent it in the following way because we know the angle between the horizontal axis and the initial velocity. So this is v0 cosine theta xx, v0 sine theta y. And there's only one acceleration for this is the gravitational acceleration in the y direction. And so then we can write down for how far it's really traveling in the y components, which is in the vertical direction, which is the following v0 sine theta t minus 1 over 2 gt squared. Because this is the initial velocity in the y direction, so we only care about how the cannonball really moves in the y direction. And then we can, because we only care about how far it's really traveling in the horizontal range, and then we can set y just equal to 0 because that's a point when it's hitting the ground. And so then we have 0, which is equal to v0 sine theta t minus 1 over 2 gt squared, because we want to calculate the time it really takes. And then we can move this part to the left-hand side, which is going to give us v0 sine theta t, which is equal to 1 over 2 gt squared. And there's one t is going to be cancelled. And then we have t, which is equal to 2v0 sine theta over j. So that's the time. So we're going to have. So when the cannonball is, so starting with the initial velocity v0, it has two components. And then this is the time it's going to reach the ground. And so how far it's really going to travel? So because in the x direction, it's just moving with a constant velocity. So it's just going to be equal to v0 cosine theta multiply this time. So it's going to give us, so 2v0 sine theta over j. So which is going to give us v0 squared 2 sine theta cosine theta. So so we can further simplify this mathematical expression into this is just equal v0 squared sine 2 theta. So this is telling us we just derive a mathematical expression like telling us that's how far the cannonball would travel with the initial velocity v0 and with an angle theta with respect to the horizontal axis, and g, which is just a fundamental constant. Um, so we can interpret it as a fundamental constant of nature, although it's changing a little bit, determine where we are. It's just equal to 9.8 meter per second squared, and we can take it as a constant. And so this is the expression we derived for how far it's going to travel. And then we can observe this mathematical expression like a little bit more to see like what does it really tell us. So what does it tell us physically? So it's quite remarkable. So if we observe this a little bit, we can tell. So theta, which is equal to 45 degree, or in radians, we can write down as pi over 4. And it's when sine 2 theta, which is equal to 1. And that's a maximum value of it, which is telling us um, the cannonball would reach. So a maximum horizontal distance when theta is equal to 45 degrees. So which is if you want to shoot a cannonball, so to make it like travel in a maximum distance horizontally, you shoot it at an angle of 45 degrees with respect to the horizontal axis. And also we can observe this one a little bit further and try to like manipulate a bit more, and we discover the following. So let's just say if I have sine 2, so 90 degree minus um um theta 1, right? So I should say, yeah, this is correct. So what so let's try to manipulate this a little bit, and this is equal to sine. I would like to write down like this by sine 2. So pi over 2 minus theta 1. And this is going to be equal to sine pi minus 2 theta 1, right? And this is equal to sine pi cosine 2 theta 1. And this is minus sign, so this is giving me a minus cosine pi sine 2 theta 1. We know sine pi is just equal to 0. And cosine pi, which is equal to -1. So this is just gives us sine 2 theta 1. And what this really telling us is whenever you shoot two angles, so let's say if theta 1 is equal to 20 degrees and theta 2 is equal to 70 degrees, so they would hit at the same horizontal location, which is I'll draw the picture, and this is, let's say this is 20 degrees, you shoot a cannonball, and this is 70 degrees, and they would hit exactly at the same place. So this is what it really means. Um, So we just derive this expression for how far the cannonball would travel, like with an initial velocity v0 and at an angle theta with respect to the horizontal axis, and then we derive like two things. So from the interpretation of it, so whenever you shoot a cannonball, like if you want to reach a maximum horizontal distance, you would shoot it at an angle like 45 degrees with respect to the horizontal axis. And then if you shoot a cannonball, so at two different angles, but the two different angles, they have a relationship, which is the sum of the two angles is equal to pi over 2. And they would reach at exactly the same horizontal distance. So that's it.